Alright, hi everyone, my name is Gabriella. Today we are working on part 1 of our exam 3 for Transpart 1. So what part 1 is going to be is we're proving this expression up here, which is e to the negative alpha k squared times t times e to the I times k times x. This problem, alpha is going to represent our thermal diffusivity. K is just going to be an arbitrary number in this case. T is going to be a position in time with respect to time. And then X is going to be our position of our nodes in this of our temperature increments. So over here we have a partial differentiation of our temperature with respect to time is equal to the thermal diffusivity times the second derivative of our temperature with respect to the position. So we're going to refer to Euler's formula when proving our expression as a solution to the unaxial time-dependent heat diffusion equation with no heat generation. And that is going to be e to the ix equals cosine x plus I times sine x. So what we want to do is basically we want to plug in this expression we were given in for our temperature in our partial differential equation. And then we're going to take the first derivative of the left-hand side and the right-hand side, and that is how we're going to prove. That is how we'll prove that this is a solution to our heat diffusion equation. All right. So first, let's take first derivative of each. All right. Sorry, I had to cut the video. I was coughing. So yeah, just to reiterate, we're taking the first derivative of the both sides of our partial differential equation. So when we do that for the left-hand side, we get negative alpha k squared. Make sure that's a little small. I'm gonna write this a little bigger over here for you. Negative alpha k squared times e to the negative alpha k squared times our time times e to the I times k times x. Okay, and then we're gonna take, next we're gonna take the first derivative of our right-hand side of our partial differential equation. And that is going to be alpha times e to the negative alpha times k squared times our time times I k squared times e to the I times k times our position. And so we have our imaginary number here, and that is just going to go to -1. And so therefore what we can do is we can do some simplification here on our right hand side, pull out the negative out front in front of our alpha, pull out our constant k squared, and that is going to be times these two right here, e to the negative alpha k squared times t times e to the I times k times our position. And when we do that, we notice that our first derivative of our right-hand side is equal to our first derivative of our left-hand side of our partial differential equation. And that is how we prove that this expression is a solution to our heat diffusion equation with no heat generation, right? And then we are going to use that, excuse me, further in our exam to solve this problem. So keep watching for part 2.